everyone. I wanted to talk about continuing on this 3D printer to CNC project. One of the things is how to get a cutting head by using the original drive mechanism and attachment point for the 3D printer. Now this is from a FlashForge creator, and this is the piece that holds the print heads. And this is just a plastic piece. The linear bearings go into here. They basically just clip in. They snap clip down, and this rides along. The belt attaches here with a little clamp that holds your timing belt onto the tray, and this just slides back and forth. It's a fairly decent unit, but it's, how do you get a Dremel or anything, a cutter head or anything on here? So what I did was I took some measurements and sat down and brainstormed, and what I came up with, for one, is to plug in this area right here. So I took, and this is made out of PET, so it's extremely resilient, and it's printed with 75% infill. And just an idea, if you're doing ABS or PLA, that's fine. ABS has a tendency to not only kind of warp a little bit, but also it will shrink. So when you take your measurements, you could lose 1 to 1.5 millimeters on the overall print size, depending on how much infill and other variables and whatnot. The PET, however, has virtually no shrinkage. So if you set this up to print 18 millimeters, it will be 18 millimeters or within just a fraction of that overall, and it will not lose it will not shrink, and you will not lose your dimensions. The only downfall with the PET is you cannot do light infill. I have struggled with that many times, and if you try 10% infill on a PET, forget it. You'll get all the way to the top, and whenever you go to do your shell print over the top of your infill, it will not bridge. PET does not bridge very well over larger areas. It has to be smaller areas. So that was the reason why I typically go no less than 50%, and even at 50% it can be sketchy over some parts. Plus PET runs at a much higher temperature. Typically the stuff I print off about anywhere from 240 C up to about 248. This was printed at 248 C. So it's a little bit warmer. Now the bed was only 85 degrees C, but I'm also using a glass bed, which works really good on retaining the heat. There's a few downfalls and whatnot to it, but if anybody wants to know more about how I print stuff and how to set up these printers, just let me know. But PET works really good. Like I said, there's very little shrinkage and very little problems, but it makes an extremely strong part. So what I did was I printed this up so that it fits right down into there, and it's nice and flush, and you can build right on top of this, so it gives you a much bigger area to build on top of. Now this is for the end of the Dremel to go into and to sit into, and what I did is I used rubber, self-annealing rubber for high voltage wire wrapping, and that's what this is. I just left the protective coating on this to keep it from sticking to the Dremel, so it can be slid in and out of. But it gives it allows you to print this a little bit larger. I mean, this is, I think I went a 0.5 millimeter larger than the OD on the Dremel to give me a little bit of a room to put something in here to kind of take out a little bit of the vibration and to keep any of that from transferring through, just to give it a little insulation. Not much, but it fits really snug into this hole. And then I have screw holes going straight through from here and here, and then I added an additional 2 screw holes back here to go into the next piece of the puzzle. Now, what I did on this is also printed in PET, and this is a pretty cool unit. This particular Dremel goes up to 35,000 RPM. You have your variable adjustment here, which I I probably won't ever use, but if I need to, I can. It's right here, easily accessible. I did put the regular drill head on the Dremel itself. And then of course it has an adjuster, I mean, or not adjuster, but your lock mechanism to be able to turn this. And what I did was I printed out this little button, put springs on a screw so that when this goes around, there we go, you can just press it from the outside, presses in that button, and then you can turn your head to tighten or loosen on any of your bits. So it was an easy way to get additional material around this to give it some security. So when it sits in here like this, so you've got some additional reinforcement around this area as well as this area here to give it as much, you know, make it as solid as possible. Now this is really solid. Once again, PET 75% infill. On these pieces here, here, this is 100% PET because it's such a small area. I wanted as much pressure as possible, and I just printed out the whole plunger and everything so that it all works. And there's a spring in here, but I also put springs underneath these screws here to give it an additional, to be able to pop out and give it a little bit more tension. So I'm not just depending on this spring here. I just don't want to, you know, if you know Dremels, sometimes these things can drag and it'll screw up your pin and you won't be able to adjust your stuff anymore. But this also has rubber inside of here attaching the motor, and it's really in there. It's not moving whatsoever. And now this goes down on top of here like so, and it fits down just like that. So it will be riding in the printer just like this, and this whole unit just slides right onto the original bearings, uses the original rods and all the original stuff. So in the future, if you ever want to go back to a 3D printer, you just remove this stuff and you pop your print head back on and away you go. The only thing that would be a residual change would be these holes back here over the larger area. So I've got 2 screws back here holding it, and then the 2 screws in the front holding it. There's not that much pressure on this front edge because it's mostly open air. Oh, another thing too, to keep in mind, this Dremel has air vents right here. There's 2 that are on the back side over here. So what I did is I left a groove when I printed this out or designed this. I left an air groove to direct the air out, and this does push a lot of air out of it. So not only is there air coming out of here, but also it gives the ability for the air to come out through on each side here, and that goes all the way around the inside of this. So it's just kind of a channel to let the air go through. And then of course I will probably be cutting this off and be hooking it up to a relay, and that relay will be hooked up to the Gerbil board so that when I turn the CNC machine on, I can control when this comes on and when this shuts off. So anyway, that's what I got for the print head. If anybody, you know, wants the STL files, I have STLs, or I have the X3Gs for MakerBot for doing this. But most people probably would want the STL files if you want to do this. If you have a need for this exact same thing, just let me know. But there you go. That's what I did for the print head. Here before too long, I'm going to have all this set up and you guys can see this in action. So anyway, that's it for this video. Please like, subscribe, share this video, and as always, you guys take care, and talk to you next time.